Hello and welcome back. In this lesson, we will continue solving systems of equations using the substitution method. When you look at the two examples that we are given this time, neither equation has a variable isolated. Therefore, our first job is to choose an equation and isolate one of the two variables. I'm going to choose the second equation. Since x does not have a coefficient, it will only take one step to isolate x. In order to isolate x, the only thing we need to do is subtract 5y on both sides of the equation. We now have an equation that reads x is equal to negative 5y plus 2. We know that the expression negative 5y plus 2 can now be substituted back into our first equation for x. When we do this, we only have the variable y in which we're going to solve for. So we have negative 2 times the quantity negative 5y plus 2 minus 8y is equal to negative 6. Using the distributive property first, we can begin our steps. Negative 2 times negative 5y gives us a positive 10y, and negative 2 times a positive 2 gives us a negative 4. Copy down the rest of the terms in your equation. Your next step is to combine like terms. Positive 10y and negative 8y are like terms. They can be combined. That will give you a positive 2y minus 4 is equal to negative 6. In order to get y by itself, we want to next remove this negative 4 by adding 4 to both sides. We have 2y is equal to negative 2. And our next step would be remove this coefficient of 2. Do that by dividing 2 on both sides. When we divide 2 on both sides, we are left with y is equal to a negative 1. We have now done the first step in figuring out our solution to this system. Y is equal to negative 1. With that, we can then go and plug y for either one of the two equations that we were given. And let's pull up those two equations. These were the two equations that we were given. You can choose either equation to substitute y in. We know that y, we said, equaled negative 1. We don't know our x term yet. We know that y is negative 1. I'm going to again use the second equation. X plus 5 times a negative 1 has to equal 2. 5 times negative 1 gives me a negative 5. Oh, that's positive. In order to get x by itself, I want to add 5 to both sides. And I know that my x term is a positive 7. So the solution to this system of equations should be a positive 7, negative 1, that ordered pair. And all we want to do is go back, substitute it in for each equation, make sure that it works. So we have negative 2 times x. We determine that x is equal to 7, minus 8 times y. Y we determined was a negative 1, and that needs to equal negative 6. Negative 2 times 7 gives us a negative 14. Negative 8 times a negative 1 gives us a positive 8. Does negative 14 plus 8 give us a negative 6? Yes. So we know that that ordered pair works in the first equation. Does it work in the second equation? Again, substitute your values in for each of your variables. 7 is x. Plus 5 times y, which we said is negative 1, must equal a positive 2. Following the order of operations, 5 times negative 1 gives us a negative 5. And is 7 minus 5 equal to 2? Yes, 2 does equal 2. Therefore, we know that this ordered pair is the solution to this system. Hopefully you've learned even more today. Thank you for watching.